Hello, in this video I'm going to show you how to find the maximum value out of a list box. And this is a pretty common academic exercise. The reason I'm using a list box, if this makes some sense, is we treat them like arrays, right? A common thing is to find the maximum or minimum value or average or something like that from a list box or an array. Array is common, list box is what we're going to use because I don't want to get into arrays yet. So anyways, I've got a collection. If you want to see what is in my list box, I can't really look at it. I can move the entire list box. But if I want to see the contents, I'm going to open up the collection. There's not that many things. You can see the smallest number appears to be -7, and the largest number is 125. I just tried to make it easy, so a 3-digit number, just so we can make sure this thing's working correctly. So I guess I'm just going to pop that out to a message box. But anyways, I want to flesh out this find max button. And so I'm going to walk you through this. This isn't going to be a particularly quick or easy example to follow, but it's a really common problem and it brings up a whole bunch of issues. So I'm going to use a while loop just to be explicit about things. And we're working with a list box which introduces a whole bunch of new problems. So dim I as integer, so that's going to be my counter. So the question is, what do I initialize my counter to? So understand that I need to go through that entire list box. I need to look at every item and find the biggest one. So I need to start at the first position, which is 1. Or is it? It's 0. Okay, so remember, computers always start at 0. We tend to count from 1, but the first position in a list box is spot 0. And then, so the really interesting thing is, who was counting how many items were in that list box? Was there maybe 15 or so? So when you think about how I'm going to set up that loop condition, am I going to hard code a number in there? What if there's 10,000 things, or what if there's 5 million things right in this list? I don't know how many there are, and you shouldn't either. So let's use the power that's available to list boxes to get this going. So I'm going to create a variable called list size. So dim list size is integer. Integer's fine because it's not going to be a fractional value. And so how do I get the list size? Well, I have to know the name of the list. It's called list values. .items.count. Alright, that's not intuitive at all. That's going to do something interesting. If there are 15 items in the list, then it's going to give me a 15 back, and I'm going to use that as my loop condition. So I'm going to write my loop now. So do while I is less than list size. Does that make sense? Alright, so we're starting at 0, and I don't know how many things are in this list. Well, now I do. There's list size things in this list, and so that's a variable. Every example I've done before this has a hard number like 10 or 30 or 50. You know, this is flexible, right? So if you add things to that list, it's going to do more repetitions. If you take things away, there's going to be less repetitions. Always smart to go down to the bottom of my loop and increment my counter automatically. Because otherwise, I'm just going to keep looking at the first thing in that list forever, right? Unless I tell it to do something else. Now, let me just cut right to the chase here and tell you why this isn't going to work. Let's say we've got a list with 50 items, right? If I want to reference those items, they're not in spots 1 through 50. They're in spots 0 through 49. So if I write a loop like this is going to cause me some trouble. I mean, I could do this with an until loop or something, but really the easiest fix is I only want to do this up until list size -1. Whereas list size, if I have 50 items, it's going to try to look at spot 50 at some point, and that's going to be an out of bounds exception, and that's a problem. So there's some more things going on here. So think about, how do I find the max? If I gave you a paper or a stack of papers and each one of them had a number and I told you to find the maximum value, you wouldn't even think about the algorithm. But I think what you'd do is you'd look at the first value, you'd assume that that was the largest thing you've ever seen, and then you'd go on to the next paper, and as you found bigger values, you'd keep that new big value. So I'm going to create a variable to keep track of the largest thing that we've seen. And I know that that list is full of integers because I saw it. And just like I said, if I gave you a stack of papers, the first thing you saw would be your current maximum. You don't know how many things are in the pile. You don't know what the largest value is. It very well could be the first thing you see. And so if I wanted to write that, I'm going to write list values dot items. And if I wanted to say I want to look at the first thing in that pile, I would write it by saying so this means look at this list box called list values, and the first thing in that pile is the thing at spot 0. Now notice I've got a problem here. Basically, it's because I've got an integer here and a list is full of strings, right? There's a whole bunch of problems that come along with this. So I need to see into that. In other words, take that string value, turn it into an int. All right, because I had a busted assignment statement. I was trying to assign a string to an integer. Now I'm doing an integer to an integer, which is good. And so it is important to initialize that first value. So I'm saying, you give me this pile of numbers, first one's the max, until we find out something otherwise. So now I'm going to go into my loop, and I'm going to need an if statement. So if, and so here I need to actually reference the current thing. So I need to say, I need to be able to come up with a way to write the current thing I'm looking at, which is, sorry, there's just no good way to say this, dot items, so the list, dot items, at spot I. Right, that means the current thing that we're looking at. So the first iteration through the loop, we're going to be looking at the first thing. You notice we kind of already looked at the first thing here, so maybe we should start at spot 1. So we're going to be comparing the first and the second thing. So if this first time through the loop is greater than the max, then the max equals that current thing that I'm looking at. And I know I have some problems. We'll need to fix those in a minute. That's probably the most annoying thing about this problem, is I'm trying to compare a number with a string, and so I need to do a cint here so that I can actually compare a number to a number. Right, and then I've got a busted assignment statement again because I'm saying this is an integer, and I'm trying to set it equal to a string. So I could do a cint on that, and now all my types are straight. And this actually is going to work. Now whether you follow what's going on is probably a different question. So let me just walk through it logically one more time. So initially I was saying, hey, we should start looking at spot 0 because the first position in that list box is spot 0. But I decided to change that. We'll talk about it in a minute. Then I picked out the size of the list by using listValues.items.count. Then I said, hey, we're going to need a variable to represent whatever the maximum value is. And remember that analogy of looking at a stack of papers. So I said, hey, the first thing in the list box, which I write that by writing a statement like that. When I start off, the first thing I've ever seen is my maximum. Now I jump into my loop, and we're starting at 1, and this is kind of confusing. So when I'm looking at spot 1 in the list, I'm actually looking at the second thing. And I'm only going to do this up until the last item in the list. And so I say if the current thing I'm looking at, which is the first time through is the second object, is larger than the first object, because I set that right here, then the new max is the second object. You notice there's no else here, right? If the second thing is not bigger than the first thing, then nothing. Our max stays where it was. If this is somehow a sorted list, then the max will be the first value, right? And this would never get executed. Let's see if this works, because you might be wondering if it does. I never put an output statement, so it might work, but I would never know. So let's do a message box. Message box.show, and what I want to print out, I'm just going to do a C string because I know I'm trying to print out an integer. And the variable that represents the max is called max. And this should work. Alright, so I'm going to click find max, and I get 125. And I told you that 125 was the largest value, so hopefully you believe me. I can browse that collection again and we can look at it. It's the only 3-digit number, so it's pretty clear, I think. And so what I want to point out is when you have problems with these minimums and maximums, usually if you're getting the wrong number, it's usually going to be 0, or it's going to be the first thing in the list or the last thing in your list. This is a weird one. I did not mean to do that, where 12 was actually the first and the last. But when you're testing these out to make sure that they're working correctly, put the number you're searching for somewhere in the middle of the list. Because if things go wrong, it usually just ends up being the first or last. That's the example. Now, whether you follow it or not, I don't know, because there's a lot of things that happen on this that are kind of tough to follow. All the cints, right? There's a cint, and a C string. So that kind of obscures the concepts. This would be one instance where maybe I could turn off option strict, and that would simplify things a bit, but that's really not a good long-term solution. But this right here effectively find the max in a list. Let's say we wanted to find the minimum, okay? Just to show you how that would work and how easy that would be. I'm just still going to use the same variable, call it max, but if I flip this inequality sign right here, simple as that. Now I'm going to find the min. And the min was a negative number. I don't actually remember what it was, but it's -7. It's the only negative number in the list. I go find max, and it's actually going to give me the min, which is -7. And if you have sound logic for the max, then there's absolutely no reason why I should fail for the min. So I've walked you through it once, wrote it. There's not a whole lot more I can say about it, but generally the idea is we're just comparing values 2 at a time. I compare whatever I'm currently looking at, which is basically this statement right here, with whatever the largest number I've ever seen is, and whoever wins that battle is my new maximum. I repeat until I get to the end of the list, and the problem is solved. Right, so more difficult solution than maybe you were expecting, but on the other hand, it also is only a few lines long, really, between 9 and 14. And if I were to use a for loop, I could have done this in even fewer lines. So, hopefully you got something out of this. And I'll check back soon. I'll be creating some more videos. I'm going to try and do more interesting problems like this. I've completed most of the ones on basic syntax. And I'm hoping to tackle some more interesting problems like this. Thanks for watching.